Now that we looked at double angle, let's take a moment to look at half angle formulas. So these are the formulas for half angle. You will notice that none of them are on your memory test. That is because all of them should be included on your reference sheet for your final. So that means you don't need to memorize these ones. You just need to know how to use them. So let's start with example 5. I want to find cosine of 15 degrees, and I want you to do it without a calculator. Now, that's a little difficult because 15 degrees is not on the unit circle. However, 30 degrees is. If I cut 30 degrees in half, that gives me 15. And now, this is a half angle formula. So I'm going to use my cosine one, and that theta on top is that 30. So that means the theta inside the root is also that 30. So I have that. Now cosine of 30 I can do because that's on the unit circle. So cosine of 30, we think of 30 degrees is right here. And I want the x value, which is the longer side, so root 3 over 2. I need to simplify this, which means the 1 needs a common denominator. So I'm going to change that 1 to 2 over 2. So then they have a common denominator, which means I can combine the numerators. And now that I've combined my fractions, I can do keep, switch, flip, which gives me 2 plus root 3 over 4. Now let's talk for just a moment about the plus and minus. The plus and minus is there so that you can determine what quadrant this angle's in. So we go back to the angle we were finding. I was finding 15 degrees. 15 degrees is in quadrant 1. So that's going to be right here. And in quadrant 1, they are all positive, which means cosine will also be positive. So I'm going to pick to keep the plus of the plus and minus. And that's our answer. So that is how we use the half angle formulas. You can cut an angle in half, which makes you able to find a lot more angles than are just on your unit circle. Now let's try one like this. I have cosine of theta equals negative 3/5. Now I know cosine is also x over r. So that means I can come over here. I want my x value to be negative 3, and I want my r value to be 5. So x is negative 3, r is 5. But notice there are actually 2 triangles that fit those specifications. This triangle down here also has an x value of negative 3 and an r value of 5. So which one do we keep? Well, we want theta to be between negative pi and 0. Well, here's 0. And if I go clockwise, negative pi would be here. So I want theta to be in this bottom half, which means I don't want that triangle. I want the quadrant 3 triangle. Now, I need to find sine of theta divided by 2. So essentially what I'm saying is right here, this is theta. Excuse me. And what I want to do is take this theta and cut it in half. So you'll probably already notice that if I take this theta cut in half, it's going to end up in quadrant 4. So that means theta over 2 is going to be a quadrant 4 angle because I take this theta, cut it in half. So now let's use our half angle formula, which is plus or minus square root 1 minus cosine theta over 2. And hey, look at that. I was given cosine of theta in the problem. Cosine of theta is negative 3/5. So 1 plus 3/5 is 8/5. Keep switch flip. Gives me plus or minus square root of 8/10, or that simplifies to 4/5. Now, let's talk about the plus or minus. We said that theta over 2 is a quadrant 4 angle. So if this is a quadrant 4 angle, that means cosine is positive in that quadrant. All the rest are negative. We are being asked for sine. That's what we want to find. So that means sine is negative. I want to keep the minus sign on this one. And that is how we use our half angle formulas. We have 2 more videos for today. We have one video where we're going to talk about our power reduction formulas, and then one last video where we'll do a trig identity. And then you'll be all done with this lesson.